Okay, okay. Dilip was on vacation. Nice. And you came today. Okay, fine.
Yeah,
Nice.
I returned from the
Okay. So Vinay, this is the Vinay and Dilip. I think Dilip, actually, you know what we are doing. I'm trying to go through the questions of MidSem DL deep
Yes,
learning. Yeah?
yes.
And this is the first question of this 2020 1101. First question, first one. So yeah, Vinay, what was your doubt actually? You got this question, or should I explain?
32 by 32 size RGB 32 into 32,
Yes.
and I got why you are doing 3
Three is
32
the
into
RGB because you know this. You know this black and white, no? It's one and zeros,
so,
right?
so if it is only one color, then it is
Sorry.
32 into 32. Got it.
Yeah. So this is
And if it is
see if
three,
you see this one, this is a matrix. Like for example, I have taken 7 by 7 pixels. So, so each one is represented by row and column. So here white is represented by 1 and black is by 0. So this is called a black and white picture. And if you take a matrix, this is a matrix. If you put this instead of this cells, you put commas and put these values here and this brackets, then it becomes a matrix. So similarly, if you go to the grayscale, we are taking from black is 0 and white is 1. Sorry, white is 255 and all the shades are different values, right? So it becomes 0 to 255 in this way. So we can represent the same matrix in this way, right? With this just put this values out and put a comma, so it becomes in this way. Then if you go to the RGB, we have the similarly 7 by 7 matrix, for example, pixels, so 7 by 7 pixels. Here also again the thing is RGB means it's a you know, this combination of red, green and blue in equal proportion gives you white, no? So the values they have taken is 8 bits, 0 to 255, and we can change these ratios. mm. And when you change the ratios, the color becomes changed. Like if red is 255 and green is 0, blue is 0, then it becomes, the pixel becomes a red. How it becomes? It's adding all the values and showing it on the screen. Right? So for this, each cell has to represent red, green, and blue. So then it becomes like this. Okay, three matrix of for one pixel, it will be having three matrix. Right. So then the matrix becomes 32 into 32 into 3. So RGB. So three-dimensional matrix. So that's the input to the first layer. If you go and check it here, it's layer 1 will be the input to the layer 1 will be the 32 into 32 into
so there
3.
will be actually 3072 cells, if I mean, or
Yeah,
items in that vector.
yeah. It's something called flatten to single dimension. It's called flattening to single dimension. There is one option
Nice.
in the Python. There is yeah. So we are giving this much of input. Yeah. So that is the answer for the first question. Now going to the second question, what will be the value of B?
Today you are talking about this, na second one, B.
No, this is B of question number 1. I am talking about question number 2A actually. I wanted to take question number 2A.
Okay.
But leave it. Maybe anyone here is who is interested in this one? Person, you already came. You already had we had
Yes,
discussion on this one, right?
yes.
Okay. Yeah, Dilip is new. So Chandrasekhar, have you gone through this one?
No, I didn't go
Okay,
through.
okay.
Sorry.
Nice. Yeah. So Prasan, can I repeat this one for these three people here?
Oh, sure.
Yeah. Okay. Thank you. So Vinay, I'll be talking to you. Okay. Others can also ask if any doubt. Okay. So it's easy to talk to one person actually. Okay. So this is a layer one. Layer one is a dense layer. They have mentioned dense means each. Oh, there's no representation. Okay. Each node, each input will be connected to this. Okay, fine. So here we have 50. This 50 value. Let's read it. Okay. Layer 1 add layers dense 50 activation. So this is one command to the in the keras. Okay. So layers dot dense. Dense means all the connections to all. It is connected heavily to each other. Let me check. Yeah, this is a dense connection. See. Here this is the input, sorry, this input is here, this is the hidden. From here it is connected to this one as well as to this one as well as to this one as well as to this one and this one. So this all the interconnections are there. This is called the dense layer. Vinay, you got it, no?
Yes, Manoj. So
Yeah.
when every cell or every node is connected to every other node, then it is
Yes,
dense.
dense. So when you say layer 1 dense means its input is connected to all the 50 nodes. So this first parameter is the number of nodes. So this first layer is the hidden layer, first hidden layer, and this 50 represents, this first value represents the number of hidden nodes in the first hidden layer. So then the activation here is value they already gave, and the input shape is A star. This one is like fill in the blanks. We need to find this A star. Now that's what we already did in this one. No? The input is 3072, 32 into 32 into 3. So it should be having, because it's dense, it's connected to all the 3072. Is connected to this all the 50 nodes. This part is clear now.
Input layer has 3072 nodes, no? Yes.
Yeah, so this is a dense layer of 50 nodes, and input is having a 3072 is connected to all the 50 nodes. That's the meaning of this one. Now we are going to the second layer, again dense layer, 40 nodes, activation is a value, and then third layer, dense layer is activation, 30 nodes and activation is again value. Then the fourth layer, dense, fourth layer is output now. It's B here they mentioned, so B we need to find, and activation we need to find, and SGD is the optimizer, stochastic gradient descent. Then the loss, again we need to find the loss function, matrix is given. So
If you want, Manoj, you can, I think if you sort of repeat it, it will take a lot of your time. Just go down it. I think we should be, reading this, and if we have question, we'll come back. Come down.
no, I think others are the only the person is there who is attended.
Acha, then
yeah,
you
yeah.
can go ahead.
Yeah, so it's not. We will go up to maybe like 9:30 if Anjani is joining. Then we can go with Anjani's session. Otherwise, we will continue. Yeah. So it's a repeated, but for me it's a good. Yeah. And talking to you is also good. You will be asking some questions, no? Then it will be nice. Yeah. So here we this is the B1. First question, inside the B there is two questions. Okay, what will be the value of B, activation function C, and loss function D if the total number of classes in the dataset is 2? So here we have in this part, this is the dense layer, output layer, and the number we need to find the number of nodes, right? B is number of nodes, right? Got it, no?
Yes. B is number.
Right, okay. And activation we need to find. See, one thing they have mentioned is the number of the classes in the dataset. What does that mean? If 2, they have mentioned 2. So there is only 2 class, that is a binary, right?
Yes, 0,
So
1.
0, 1. So 0, 1, we can, I just mentioned here in detail. So therefore the last layer as before, which means output layer. Sigmoid provides just 2 outputs, 0 and 1. Right? So this is a Keras code. Different activation value functions are available. So I am not going into this Keras page. It's having different activation details there. But generally for 0 and 1 binary classification, we are using sigmoid. Okay. So that's also the university answer, sigmoid, for the activation. Now number of layers, number of nodes. How many number of nodes are required? Can you guess? We need only 2 output, right? 0 and 1. So 1 node is enough, no? Only 1, 0 and 1 you can get from 1 node, no? Sigmoid out is 1 and 0, right? Vinay, can you unmute?
Yes, only 1 node. Yes.
Yeah. So so that's it. So you got this one also. Node B is 1. Activation is sigmoid. Now see, for binary, this one, sigmoid is binary classification. For binary classification, generally we use loss function as a binary cross entropy. This is a default, something like a default. Generally we use. Okay. So it's also hence let us go through this details. This first argument denotes the number of nodes. As per the we have the two outputs. Single node with a sigmoid activation can provide two outputs. Hence our answer is B1, B is equal to 1, and C is a sigmoid. This is just a graph representing that. The loss function for the binary classification is given here. If you go there, you will find so many. So here I have taken a screenshot. Binary cross entropy, hinge loss, and square hinge loss. So again, they have mentioned it's for the SVM. Hinge and square hinge is generally used for SVM. Cross entropy is the default loss function for the binary classification. So I think this explanation is enough, more than enough for this answer, no? Right? Yeah, if you want you can go through this one in case. Yeah. So then B2 we are going to the next question in the B2. That is they are asking the question same B and C and D we need to find, but number of classes in the dataset is 10. Right. So in the 10 then we need 10 classifications. So each one will be 0 and 1. No? So we need how many nodes?
10.
10 nodes, yes. And the activation generally used for categorical classification is called softmax. Now we will have a small discussion on softmax, what it is. Layer 4, so it's something like this, and the function there is a softmax. The output is logits, and each one having its own probability and all. So softmax is a function that will convert the, for example, if this is 0.6, this is 0.5, this is 0.8, so total probability will be more than 1, na? Right? So in order to avoid that one and keep probability to 1, we are using the softmax. And also within that there is one extra something which I have highlighted here. Let's go through this. This is something like an important one. So layer 4 is the last layer as per the code, which means output. In this question we have 10 outputs, hence sigmoid can't be used. No, commonly used activation function is softmax. It's mentioned in this, and there's some small video on that, detailed video on that. The output of the sigmoid function was in the range of 0 and 1, which can be thought of as probability. Yeah, output of sigmoid. No, this is a ReLU, right? Sigmoid is only 0. So this function traces certain pointers. Suppose we have 5 output values 0.8, 0.9, 0.7, 0.6. How can we move forward? We can't. The above values doesn't make sense as sum of all classes output probability should be equal to 1. This softmax function is described as combination of multiple sigmoids. It calculates the relative probability similar to the sigmoid logistic activation. The softmax function returns the probability of each class. So again we are returning the probability of each class with the total probability of 1. So here it is not the total is different. So the most commonly used activation function for the last layer for the neural network in case of multi-class classification is sigmoid. Okay, I mean softmax. Sorry. So here we are using exponential of zi divided by sigma of exponential of zj. So here what we do is we add all the we take exponential of each and every one, each one of them, and then add them together as I am put it in the denominator, and for each one we'll find this one. Why we do this exponential thing is mentioned here. So let's go over a simple example. Assume that you have 3 classes, meaning there would be 3 neurons in the output layer. Now suppose you have output 1.8, 0.9, this is point. Apply the softmax function gives a probability to be, we will return the following outcome: 0.58, 0.23, 0.19. So softmax output will be like this. The function returns 1 for the largest probability index, while it returns 0 for the other 2 arrays. Yeah. So here giving full weight to the index 0 and no weight to the index 1 and 2. Okay, so here it gives the highest. Softmax takes the maximum of that one. All others will be 0. So the output will be class represented to the first neural index 0 out of 3. You can see how softmax makes things easily for the multi-class classification. In the multi-class classification, we need only one output to be 1, right? All others has to be 0. No? So it takes, first of all, it takes a probability in this way and then makes it 1, the highest one. Logits interpreted to be the unorganized, not yet normalized predictions of the outputs of the model. This can give result, but we don't normally expect with logits. So this logic thing is explained here. We are not going deep into the logic here. Just it's in the output we are using logits. Since output of logits may sum up to more than one, so normally we use again is repeating. To normalize we use softmax, which has exponential function as discussed above, which overcomes the overwhelming constant issue. So what is a constant issue? See, if you have output 10 and 11, the softmax gives 1 by 3 and 2 by 3. That is 33 and 66, right? Yeah. Okay. The squared version gives us approximately 0.45 and 0.55. This is the some other method, squared method. Okay, 0.45 and 0.55. Again, if the outputs were 100 and 101, softmax would still give 1 by 3 and 2 by 3. So it will be still 33 and 66 now. But the squared version will give 0.495 and 0.505. These two are very near, right? Whereas this 2, 4. I think, are you getting this one? This is the most important part of it.
The proteins output 10 and 11 also give us 1 by 3. The square version gives us.
Anyone has any doubt on this one? This softmax thing, anyone has doubt?
It's okay.
Okay, when you got it, what is the difference between this? If you have here 1000 and 1001, the output will be very small difference between them, right? But softmax will be giving again 33 and 66.
Yeah, because it is exponent. No?
Yeah, exponential. Yeah, it will remove the constant issue. This is a constant issue. So from this example, it's clear that softmax only cares about the difference, whereas the coed version cares about the location. Guys, anyone, Dilip, are you able to get it, or what we are discussing?
Yes, little bit.
Yeah.
Oh, nice. Chandrasekhar,
I just attending the first class today, so I will try to go through.
no, I was explaining for the beginners only. You
Yeah,
got
I'm
this one?
getting, but not fully, but I'm able to get.
Anything you missed here, let me know. I can just go through that for the benefit of others also. Which one you missed? This one you missed, or 32 into 32 into 3? You got this?
No. No, that is also, yeah, I'm not sure
So,
how it came.
yeah, one question I also have, like how this pixel thing is being taken.
Oh, okay. So maybe you joined late. So we already have a discussion like black and white. We have the sun. For example, you're taking sun. But Panimiller, you know this? Are you able to?
Yeah, I'm familiar with this. Like I also know that the RGB thing is there.
Okay. So here we have this sun by sun pixels. You know this is only represented by 1 and 0, right? This
Yes.
you got this matrix, no?
Yeah.
Got it? Because here 1 is representing the 0, I mean white, and the 0 is representing the black.
Black. Okay.
Right? So if you take these values and put commas here and put it in the bracket, it becomes the matrix.
Matrix.
7
Yeah,
by 7.
okay.
This is simple, right?
Yeah, this is.
Okay. So let's go to the grayscale again. 7 by 7 pixels. Some are white, some are black, and some are in having a different shade. So here the white is represented by 255, black is by 0, and all other grades shades are represented by some other values, in between. So this is also clear, or?
Yeah. So how this number thing, like 77128, is it
Yeah.
randomly?
No, it's see, this is 0 black and 255 is white.
And
So
then
when you change it,
accordingly
yeah.
that ratio there. Okay.
Yeah. So shade, as per the shade, increasing to white will be increasing the value, and decreasing to 0 will be making it more black. So this is like a 8-bit representation of the grayscale. 2 raised to 8 now. Now this values you are putting into the putting the commas and into the bracket, it becomes a matrix. So this is again 7 by 7 matrix. No? If you go to RGB, what happens is each cell, each pixel you need to represent by red, green and blue, all the three. So each value will be 0 to 255, for example, 8-bit. If it is 8-bit, there can be 16 bits, there can be 24-bit RGB also, but here we are just for convenience we are taking 8-bit. So each cell will be represented by 3 colors, because it's a combination of the colors that will give you the output. For example, if you have 255 and 255, 255, 255, so this will be like white, particular.
Yeah, correct.
So this 3 layers has to be there, so it is called 7 by 7 into 3. So similarly, in the question we have 32 by 32 pixel RGB, so that means 32 by 32 pixel, and again 3 matrix will be there, so 3 into 3.
Okay, now understood.
Yeah, fine. So what else you missed? What are these things?
Yeah, I was when you were going through softmax, then I joined.
Softmax, okay. So this one you got, no? A is this input. So here we have first. Chandrasekhar, are you able to follow till what this RGB thing?
Yeah.
Okay, and Dilip also, right?
Yes.
So this is model preparation in B.
So do you recording this session? Maybe we can record with this.
I already did 2 sessions of the same thing. I have already recorded that also. This also I am recording.
Yeah.
So share the link.
Yeah, it's already shared in the group. Again, I will share it today also. No problem.
Okay.
So
But try to understand this. This is a very simple thing. Try to understand and ask me any question now itself. So no need to go to a recording again.
so this 50 thing is like we are
Okay, I'll tell you this
dense
one.
layer.
This one is first one is the okay. Vinay, I think Vinay can explain you because he just now learned and it will be good for him. Vinay, would you like to?
Yes. So you're talking about this y 32 into 32 into 3, right?
That is done, I think.
Yeah, that we just got it. I got now.
And
Anyway,
why,
okay.
why deactivation function is right?
Yeah.
Why?
So why we took 50 only? That is my question.
Oh, 50 is given by the question. It is not what we chose.
Okay.
It is given by the question. So generally what happens is there is an input layer, and then there are hidden layers.
Yes.
So hidden layers would try to tease out more complex relationships, right? So you can think that first 307 to 3072 nodes, each one of them will get connected to 50 nodes,
Okay.
right, of the first hidden layer. There would be some relationship which will come out of that, and then in the second hidden layer, these complex relationship will get even more complicated by each one of those 50 layers, 50 nodes which had some combination of 307 to 72 nodes in each one of them, again sort of so getting mixed up to create a more complex relationship. That's how it
And
goes.
that would go into 40 node.
Yes, and then 30,
And this, I also want to understand this ReLU thing.
yeah.
So
So-
why it's being given twice? So each time we need it, when we pass to next layer. So like we have two dense layer here, I think. Three dense layer. So every time do we need to give the activation?
Every time you are getting into a hidden layer, so see, think of it as a machine, hidden layer as a machine. It will receive some input, and there will be some activation function in it, right? After you can think of it as some modification which will be done to all the values which are coming in.
Yeah. Okay.
Something comes in and it will do something with it. What it will do is notified by your activation function.
Okay.
So this function returns 0 if it receives any negative input, but for any positive value it returns that value back, max of it. It is sort of max of it. Whatever comes in,
Yeah.
it will take the max of it.
Okay. Yeah. So we need it as at incidence level.
Not, I mean, it can be other function also, but here we are using rectilinear. Yes.
Yes.
It
So
helps.
it's not like we can give in like last dense layer. Like
Last dense layer, we need only two output, right? We need 0 or 1. If that is the case, then rectilinear function is not the binary function. You need a binary activation function.
Okay, can I intervene? Yeah, actually,
yeah.
uh, here we are not interested in finding why they used a ReLU and why they are putting 40 here or anything else. We are just taking for this because we are not going to do deep concept of this one, because in the university our bits will be taking the sessions, that time we will be able to
Yeah.
understand better. So
Yeah,
here we
yeah,
are just
correct.
trying to get
Yeah,
a
we can
overview
just
of this one, a high level information on
yeah,
this. So
sure,
yeah.
sure.
So here your question was why B, right? What is B? B is the number of neurons we need. So here the output is only binary, right? Only 2 are there, right? If you check the question, if the total number of classes in the dataset is 2.
Yes.
So with this we need only binary out. So one neuron can have 2 out, no? Sigmoid, if you are giving a sigmoid for activation, it can give 0 and 1, right?
Yeah, correct.
So that's why we are using sigmoid as the activation, and number of neuron is 1.
Yeah. Okay.
Got
Yeah,
it?
got it.
Yeah.
Up to that I have.
Yeah, and then the third question is the D. D is the loss function. Loss function for the binary, this is a binary classification. So for binary classification, we are using a loss function, binary close entropy, and this is more or less like default. There is some other loss function also, hinge loss and squared hinge loss. This is used for SVMs.
Okay.
And close entropy is the default loss function for the binary classification problem. So I have mentioned all this, collected all this information in this document. So this question is clear, no? Now this, what is clear? Right?
Yeah, I understood.
Yeah. So we are not going deep why they are using accuracy metrics and what, because then we will be.
No, that is fine. I just
Yeah,
want
we just need to have an overview of
yeah.
what is to expect in the. And so
Yeah,
with that we can go through the slides and all to find more information, I think. Then we can come again together and discuss further. Yeah. So Dilip, are you able to get it? Dilip returned from a vacation, I think.
Yes. Yeah.
Okay. And Chandrasekhar, you got it? Yeah.
Yeah, thanks.
Fine. And Sachin was asking, right? Sachin,
Yeah.
are you there? Yeah. Okay. Fine.
Yeah.
Fine. So the second question is similar to that. Only thing is the data set is having 10 classes output. Okay. So how many activation? I mean, how many neurons will be required? Anyone? So 10 output means 10 neurons will be required. Each will be 1 and 0, right? Guys, answer, okay.
Come again.
Yeah. I mean, 10 outputs are there, no? 10 classes. 10 classes
You want me
means.
to answer?
Yeah, someone has to answer, no? Yeah, okay.
That will be 10 in the end, right? Because it is a last layer.
Yeah.
So you would need 10.
Yes, yeah. So 10 output. So 10 output will be having each maybe some sort of activation, but in the categorical classification we use softmax, and the reason I already explained. Can you explain, Vinay? Maybe let me see how much I was able to convey.
Softmax, see, so when you have a categorical output, right? I mean, in binary, we were using which one? If you guys can answer, we were using sigmoid, right? And there is another one which is softmax, which will give you between 0 to 1, but for each category. Am I right?
Yeah, the total
Yeah.
probability will be 1 for the 10 outputs. For this output, if you add for the softmax, output will be 1 probability, but individually this logic will be having different probabilities, like 1.8, 0.9, 0.68. So the output
Then you cannot say the total will have 1. Then you can say that there would be something which will make it 1.
exactly. So that's why we are using the softmax to find the total values in the total probability and find the highest probability one, put it as 1, and all others as 0. And this is a calculation of the softmax. Can you explain this one?
Yeah, so what is happening is that for every single output, softmax, for example, if it throws probability 0.8, then it will take exponential of 0.8 plus whatever all the 10 node which are given. So exponential of, say, for example, 0.1, exponential of 0.2, and it will take sum of it, right? And the value would be of individual output divided by the sum of total outputs. Exponentials. It will take exponential of all of them.
Yes. So, guys, did you get this softmax thing? Anyone? This very simple thing. Banshidhar, you got? Or Dilip? Yeah.
Yes.
Anyone having doubt on this softmax things? Okay, I think I don't know. Yeah. So let's go to the softmax. The loss function used is categorical cross entropy, and this is a default loss function used with softmax. So we got this answer. B is the number of neurons 10, and C
I
is
was not very clear on this. So individual value can be anything, but the final value has to be between 0 and 1.
yeah. So because each one has to be 0 and 1. That's the point actually. So first.
No. What happens, Manoj, is that there will be some value, and they will be forced between 0 and 1, right? And so what happens is, wherever it is crossing more than 0.5, it will probably give 1. I need to look more closely to it, but yeah. So after you put in values,
It is not like how it works. Like if you have 10 nodes in the final layer, so see, when you are using softmax, how it's going to give you the change. I mean, you can have value ranging from 1 to 100, right? When you're receiving the values from the previous layers in the hidden layer, you put it in the output layer, the values can range from 1 to 100. But how you will convert it into a probabilistic range is how the softmax focuses and how it acts on it. Like it will take those numbers and raise it to the exponent. The exponent is a constant. It's something of the value like 2.7, 2.7134, something like that, right? And so constant. So whichever number you raise it to, it will give you another number which ranges from 0 to 1.
Right. You're right. 0 to 1, and it has to all sum up to 1. That's what softmax does.
Yes, you have to sum it up for all those neurons in the output layer. So you will get a probability of which neuron has more weight If the dog has more weight, it will convert.
Got it. Which node has the more weight? Got it. Got it.
Exactly. Yeah.
Got it. So
Okay.
if for example everything has 0.2 as a weight and dog has 0.3, then the model is outputting that dog. The label has to be the dog.
Yeah.
Yes. Got it.
Okay, my question, my only doubt here is whether the output will be 1 and 0 for all this, or it will be a value between 1 and 0 for each one.
Between
So
1 and 0,
all the
all summing
values,
up to 1. You
yes,
go ahead.
sum it up to 1. It will sum it up to 1. Yes.
That's okay, but somewhere I have read it like it should be 0 and 1 only for binary classification. Like each one will be a binary classifier, like 0 or 1, 0 or 1, 0 or 1, 0. Like the softmax, what it does is it takes what you said is right, from 0 to 1 it will make, and then the highest probability part, or for example if Apple is having 0.7 and all others are like less than that, it will make Apple as 1 and all others will be 0.
Yeah, you are right. You can think of it finally as like this.
Yes, so that's what I have read it, but I missed to
No, but
add
it does
that
not
information.
do. It does not do 0 and 1. What it will do is internally it will pick the label which has the highest probability. So
Exactly,
you can think
yeah.
of it. You can think of it as doing a 0 1, right?
Yeah, because if you read here, it's yes and no. It's not between yes and no, right?
So
It
what
will
is
be 0.
happening here? So what is happening here is that each node, you can think. You know about logistic regression.
Mm-hmm.
Logistic regression gives value of yes or no, right? Probably. You can think of every. So for example, there is a value which it finally give it to the last layer, and the value is between 0 and million, 1 million, right? And then what Prasoon was saying, that if it is 0 to 1 million, it will take that 0 to 1 million as exponential. Right? What does that do actually? What does that do? When you take the exponential of something and divide by the sum of exponent of all the values, it will force it between 0 to 1 plus sum of all values have to be 0, has to be 1.
Yeah, that's all done. From this part we have done everything, and we have come to the place where all the probabilities submit to 1. But after that there is one more something happening here, and this I am sure, I think this is a part of the softmax where the highest probability thing will be outputted as 1 and all others will be 0.
Yes, you can think of it. Yes. So for example, Apple has probability 0.3, right? And all others 4 have some 0.17 something, right? So if Apple has highest probability, then it will output your value as Apple. Your label will be labeled as Apple.
Exactly, yeah.
So it is a probabilistic model.
It becomes probabilistic model, yes.
Okay, now let's go to the next one. So what will be the total number of parameters in the layer 1? We'll go one by one. Okay, so what is the total number of parameters in the layer 1? Suppose this is the input layer and this is the hidden layer. So for example, we can take here, we want to know the parameters of the layer 1. Layer 1 is the first hidden layer. Okay, so what are how many parameters are there? It will be from the each input we have one weight associated, no?
Yes.
Okay, so each one having a one weight, and each neuron will be carrying one bias, right? So we can say if you have 3 zeros, you have 3072 inputs, no? Input we already, and then we have this 50, that is 50 number of neurons in the first layer. So 3072 into 50 will be the number of parameters weight, right? That will be number of weights, right? For example, we have 1 2 3 4 hidden layers, and input is 1 2 3. So for the dance it will be 3 into 4, that is 12 weights, no?
12 edges, yes.
Yeah, 12 edges, exactly. So we have, this is the and then we have the 50 neurons will be having 50 weights. we will add plus 50
bias.
bias. Yeah, got it, Vinay?
Yep, got it.
Yeah. And going to the second one, the output of the first layer will be only 50. No, 50 nodes are there in the first layer. So output 50 will be going to the second layer. Second layer is having 40 nodes. So weights will be 50 into 40 and then 40 bias. Got it?
Sorry, Manoj, I have some doubt. Like,
yeah, sure.
Bias is per layer or is bias is per neuron?
Per neuron.
I still have my this thing because last time when we studied, during Professor Manali's this thing also, the bias is exactly negative of the negative equal to the threshold, and negative equal to the threshold is for the complete layer. She said.
Yeah, I remember. Yes, she said something like that.
No, it depends on the model and everything. You can make it like that. You can make different things like that. In the second question, we have this doubt will be clear when we go to the second question. This is the first question. So anyway, it is like per neuron. Each neuron is having a different bias, and this bias will be changed. We are not changing the bias of a particular layer only.
Okay. Take
it. Yeah. So let's take it in this way only. Yeah. For the time being, at least. So this is the answer given by the university. Okay. By the way. So don't need to. Maybe that's a different context where she explained. I didn't go through that, so I don't know what she was saying. So for each neuron we have a different bias, and for each weight edges we have a different weight. So total we know. So this calculation is pretty forward simple, right? Everyone knows this, right?
Yes. Well, when we'll start sort of working on it, there is a model summary which we will see when we start doing it in Keras. Okay.
Oh, okay.
So
good, yeah.
Model summary we will get that thing.
So meantime, this calculation is everyone knows this one, no? It's quite simple and straightforward, right?
Yes.
Okay. Any doubts? Anyone else? Please ask. Okay. Now, so then this is a totaling of all the values, and now they are asking one important question. If a dropout layer of value 0.5 is added after layer 2, what will be the change in the number of parameters? So see, what happened is dropout means, guys, why we are using this dropout, and what is the main issue with the DNN, dense deep neural network. What's the major issue we found in compared to the machine learning? In the DNN we have multiple layers, no, that become complicated, and the system learns very well. So it learns too well that there is a overfitting happening, right? Because all the values of the test cases will be learned by the system, but when you the training set data will be learned by the system model, and when you give the test data, it will suffer because it has overlearned. So what you are doing with the dropout is that you are just cutting off many of the neurons so that the model becomes less complex, becomes a simple model. For each iteration it will cut off a particular surface. So here we have mentioned 0.5 is the dropout layer, no? So that means half of the neurons will be cut off. So that means half complexity. The system will be having a half complex. So it will not learn properly all the weights, all the data of the test training set. So it will be still a simple one. But for after each iteration, the neurons that were cut off will be connected back, and those who are connected will be cut off, and vice versa. Just 1 minute, okay? This noise is there. Maybe Vinay, you can continue for a minute.
Drop out during training.
Okay, it's okay, fine. So, so this is are you able to understand this? Why the dropout was introduced? By dropout, we try to avoid overfitting in the DNA. It's the only purpose we are using the dropout. And there is other things also like regularization, which we will learn in the next. So yeah, here is all the L1, L2 regularization. So in dropout, the dropped out nodes weights remain, but they are not affecting the system. So this weights will be, but this weights are available, but this neuron is cut off. So this is not affecting the system. So dropout affects only during the training to fit the model. So when you're training it, this dropout comes in place, and once it's fully trained, there's no more dropout. It's still normal. So during the test, all nodes and weights are in play. So the answer is if a dropout layer is 0.5 is added after the layer 2, what will be change in the number of parameters? So there is no change in the number of parameters even if the dropout is added. This is the answer by the university. So you got it? Or any doubts on this dropout thing? Why is no change in the number of parameter?
You can go ahead.
You got it or?
Yeah.
Okay. Panimala, you got it? Sorry, can't hear you. What? Okay.
Hi guys.
Hi Anjani. Yeah. Okay. We will hand over to Anjani now.
Okay. So what you're explaining? It's look like same thing, right?
It's a question paper answering of the MidSem.
Okay.